Hello students, welcome you to this video. In this video, I am going to start chapter number 7, one of the very simple chapter, matrices and determinants. So what I have planned for every exercise, I'll teach the concepts and some of the most important questions in that exercise and example. So if you are thorough with that concepts and these sums, I am sure with little effort, you can do the remaining sums. So today I am going to teach you exercise number 7.1. First, the basics of matrices you need. Already you studied in 10th standard. For matrix, what are the different types of matrices, how to add, when can you say two matrices are equal. Everything you would have studied already, right? And the order of a matrix. Then multiplication, that's something important. So you can't simply multiply any two matrices, right? Suppose if you want to multiply two matrices, suppose A's order is M by N and B is another matrix, the order is say P by Q. AB exists only if these two are equal. These two, that is N equal to P. That is number of columns of the first matrix is equal to number of rows of the second matrix. Then only you can say AB exists. Matrix multiplication is not commutative, but matrix multiplication is associative, right? AB need not be equal to BA. Some rare cases they may be equal, not in general. But associative property satisfied. A into BC is equal to AB into C. Then if you want to find A square, don't simply square it. You find A into A, right? Multiplication in practice, row by column method that you have to do that, okay? Then transpose, that's important. Listen, suppose A is a matrix, 2, 1, minus 3, 1, 4, 5. You know the order of the matrix, there are 2 rows and 3 columns. So the order is 2 by 3. Transpose, denoted as A transpose, A power T. Interchange rows and columns. First row, what is the first row here? 2, 1, minus 3. You write it as first column. Second row, you write it as second column. Now see the order, 3 rows and 2 columns, so 3 by 2. So A's order 2 by 3, then A transpose order 3 by 2. 2 by 3 become 3 by 2 because we are interchanging rows and columns. So number of rows and number of columns also will be changed. Some of the properties of transpose, very simple properties. If you take 2 times transpose, you will get the original matrix, right? A transpose, the whole transpose is equal to A only. Then for addition, A plus B transpose. Separately you take A transpose plus B transpose. Same way for subtraction also. A minus B transpose is A transpose minus B transpose. Multiplication alone you have to be very careful, right? You have to reverse the order. AB transpose is B transpose into A transpose. You cannot reverse it. You can't change the order because you know it is not commutative. So AB transpose is B transpose into A transpose. This transpose is only for matrix, not for scalar. Suppose some 5A. 5 is a scalar, right? Don't take 1 by 5. No, 5 you write as it is only for A, you take transpose. Suppose I am taking a constant scalar K. KA transpose. KA transpose where K is a scalar. Then KA transpose is K is a scalar, so K you write as it is, K into A transpose. Suppose K is a matrix, then you know reversal order, right? A transpose into K transpose, right? Then symmetric matrix and skew symmetric matrix. Some of one important definition is there. Symmetric matrix and skew symmetric matrix. Suppose a square matrix is given. Let A be a square matrix. To check whether it is symmetric or skew symmetric, you find the transpose of the matrix. So you find A transpose. If your answer is A itself, we say it is symmetric. If your answer is minus A, we say it is what? Skew symmetric. Okay. To find symmetric and skew symmetric, first of all, the matrix must be a square matrix. A square matrix A is said to be symmetric if A transpose equal to A. It is skew symmetric if A transpose equal to minus of A, right? But one thing you have to remember, one important result. Every square matrix can be expressed as a sum of 2 matrices. One is a symmetric matrix, another one is a skew symmetric matrix. So that's an important result. I'll tell you how to find the 2 matrices. One is symmetric, one is skew symmetric. And based on that, we have questions. They may ask, they may give a 2 by 2 matrix or 3 by 3 matrix. So that's very important one in this exercise. Every square matrix can be expressed as a sum of a symmetric matrix and a skew symmetric matrix. Okay. Suppose A is a square matrix. A can be written as P plus Q. A is equal to P plus Q, where P equal to half into A plus A transpose, where P is half into A plus A transpose, and it is symmetric. How do you know it is symmetric? Please listen. What is the condition for symmetric? If you take transpose, you have to get that matrix itself, right? Let us check with, say, P transpose. What is P value? Half into A plus A transpose, right? For this, the whole thing you take transpose. Half is a scalar, don't take transpose, right, as it is. Only A plus A transpose, the whole transpose, right? It is addition only, no? So half into, first one is A transpose, first one's transpose. Now second one's transpose. Second one's transpose means A transpose, the whole transpose. So that is half into A transpose plus A transpose, the whole transpose is what? A. So half into A transpose plus A transpose plus A, or A plus A, addition commutative only multiplication is not commutative. So this is same as what? P. So you are getting P transpose is equal to P. So you can say it is what? Symmetric. So A equal to P plus Q, where P is half into A plus A transpose, which is symmetric, and Q is, instead of plus you put minus, half into A minus A transpose, and you can prove same way you can prove it is Q symmetric. For that you take Q transpose, you will be getting minus of Q, right? So that is Q symmetric. That proof you can try. Okay. So remember, every matrix, every square matrix can be expressed as a sum of two matrices. One is symmetric, another one is Q symmetric, and the symmetric matrix is half into A plus A transpose, and the skew symmetric matrix is half into A minus A transpose. Now only thing you have to check, when you add P and Q, we have taken some values for P and Q, no? While adding, we have to get A. Now let us check that one. So you find P plus Q. P plus Q. P is what? Half into A plus A transpose, plus Q is half into A minus A transpose. What is common in both? Half is common, take it out. What is left out? A plus A transpose plus A minus A transpose. A transpose cancel, A plus A, 2A, 2 cancel, you are getting A. So A is equal to P plus Q, right? A is equal to P plus Q, where P is symmetric and Q is Q symmetric. Okay, this is the only thing new. All the things already you studied. Okay, so now based on that, let us practice some questions. Look at the first question, very simple one. Construct a matrix, right? But you do very carefully while writing the order and all. Construct a matrix M by N, where A equal to Aij, where Aij is defined by, every question they give some function, right? Some relation they give in terms of I and J. I is the position of row, J is the position of column, right? Which row, which column. So here M and N, order is M by N. M and N, they given the value. M equal to 2, N equal to 3. That is 2 rows, 3 columns, right? 2 rows, 3 columns. So order of the matrix is 2 by 3. 2 by 3, 2 rows, 3 columns, right? 2 rows and 3 columns. So you take it as A is the matrix, A11, A12, A13, A21, A22, A23. So this is our answer. We find all the 6 elements and substitute. Using this relation, Aij is equal to I minus 2j the whole square by 2. They can give any relation. Sometimes they give modulus. Modulus means absolute value. Even if it is negative, you take it as positive, right? So first you find A11. So this is what Aij, right? You find A11. What's the meaning of A11, you know? This is instead of Aij, we have A11. That is for I. Instead of I, you put 1, and for j also you put 1. In the relation, for I you give 1, for j also you give 1. So for I you give 1, 1 minus j also 1, 2 into 1, 2. 1 minus 2, the whole square by 2. Square is only for numerator. 1 minus 2, it is minus 1 the whole square, so 1 by 2. A12, I is 1, j is 2. I you give 1, 1 minus j is 2, so 2 into 2, 4. The whole square by 2. 1 minus 4 is minus 3. Minus 3 the whole square. So plus 9 by 2. Like that you find A13. I you give 1 and j you give 3. I is 1. 1 minus 2 into 3. 2 3s are 6. 1 minus 6 minus 5 the whole square 25. So 25 bit. Like that you find A21. I is 2. J is 1. A2, 2, I2, J also 2, A2, 3, I is 2 and J is 3. I is 2, 2 minus, J is 3, 2 3s are 6, 2 minus 6, the whole square, 2 minus 6, right? 2 minus 6, the whole square. So minus 4 square, 16 by 2, 8. All these values you substitute in A. Okay, so if you want, you can, 2 is not common, only the numerator. If you want to take 2 common, then here you have to put what? 2 is not common, you have to put by 2. 1 by 2 you take outside means you have to multiply by 2. So no need, you just leave it. This is enough. Okay. Only the numerator, denominator is 2 is common. Here it is not. If you want, what you can do, 2 can be written as 4 by 2. Then take 2 outside. 8 can be written as 16 by 2. Then 0 is 0 by 2, no problem, right? Then if you want, you can take a half outside. Then you can write it as what? 1, 9, 25, 0, 4, 16. If you want, you can write like this also. Both are correct only. You can use any one of them way. Okay, now we go for question number 3. Determine the value of x plus y. Read the question very carefully. Determine the value of, it is not x and y, it is x plus y. So sometimes it happens, we find x and y, we leave and come. So always read the question very carefully. Determine the value of x plus y. So after finding x and y, you have to add it. Okay, otherwise it's a very simple question. 2 matrices given and they said the matrices are equal. What is the condition for equality of matrices? 2 conditions. Orders must be same and the corresponding elements are equal. Orders are equal. Here the first matrix order 2 by 2. Second one also 2 by 2. Okay, orders are equal. Then the corresponding elements are equal. What's the meaning? First element equal to first element, second equal to second, right? Third equal to third, last equal to last. Okay. So you can say first one equal to first one. That is 2x plus y equal to 7. You will get one equation in x and y. 4x equal to 7y minus 13. You will get another equation in x and y. So 2 simultaneous equations in x and y. Yeah, of course, you can solve it. If you have some other easy way, you go for that. Listen. If I take the last one, very easily you can do, no? 4x equal to x plus 6. 4x equal to x plus 6. Combine x terms together, 4x minus x. So 3x equal to 6, x equal to 6 by 3. It is 2. Very easily you can do that, right? Any one of the value, which is easier there, you can use it, okay? You will get the same answer in any method you do. X equal to 2, now y we have to find it. For that you take anything. Even the first one you can take. 2x plus y equal to 7. 2x plus y equals 7. X value 2, substitute here x value 2. 2 2s are 4 plus y equals 7. Y equal to 7 minus 4, it is 3. X value, y value, got it? Don't stop. What they asked in the question? X plus y. So x plus y equal to 2 plus 3. The answer is what? 5. Now, sum number 5. Listen. If A is a matrix, compute A raised to 4. A square, how can you find A square? A into A. How can you find A cube? First you find A square, then A cube is A square into A. But here they asked to find A raised to 4. So first you find A square, then A raised to 4 is A square into A square. Okay, so all of you know how to do that, but still the multiplication we will see one more time, right? So first you find A square, A into A. So write A 2 times. Now you know how to multiply row by column. First row, first column, 1 into 1 plus A into 0. A into 0 is 0. 1 into 1 is 1. That's all. First row, second column. First row, second column. 1 into A. A into 1. A. So A plus A, you are getting 2A. Right? Now we come to the second row. Second row, first column. 0 into 1. 0. 1 into 0, 0. So 0 plus 0, it is 0 only. Now second row, second column. 0 into A. 0. 1 into 1, 1. So you are getting just 1. Right? So this is A square. We want A raised to 4. So A raised to 4 is A square into A square. So A square already got it. Write that 2 times. Again row by column. 1 into 1. 1, 2A into 0, 0. So 1 plus 0. First row, second column. 1 into 2A. 2A, 2A into 1, 2A. So 2A plus 2A, it is what? 4A, right? Now second row, first column. 0 into 1. 0, 1 into 0, it is 0. So 0 plus 0. Second row, second column. 0 into 2A, 0. 1 into 1 is 1, right? So you are getting 1, 4A, 0, 1. Now let's move on to question number 7. Very simple question. If A equal to a matrix, there is an unknown. They asked to find the unknown. one condition given. What's the condition given? A minus 2i into a minus 3i equal to 0. 0 means it is 0 matrix. What order you should take? A is a matrix 2 by 2, so you take 2 by 2 0 matrix, 0, 0, 0, 0, right? So what do you do here, First you find the first bracket. What is that? A minus 2i. You find a minus 2i separately. This is a minus 2 into I. I means identity matrix 1, 0, 0, 1. If it is a 3 by 3, you take I3. 1, 0, 0, 0, 1, 0, 0, 0, 1, right? Here it is I2. Do you multiply by 2? Minus you write as it is. You multiply every element by 2. Then ordinary subtraction. You are getting the first one, that is what? A minus 2i. Next you find a minus 3i. How can you find a minus 3i? A already given minus 3 into I. I is 1, 0, 0, 1. Multiply by 3, subtract. Both you got it. Now you write the expression. Substitute for the first one. Substitute this matrix. For the second one, substitute this matrix. Equal to 0. 0 means 0 matrix. 0, 0, 0, 0. Again, row by column. First row, first column. 2 into 1. 2. 2 into minus 1, minus 2. First row, second column, 2 into 2, 4 plus 2 into x minus 3, 2 into x minus 3, that I multiplied and write, okay. 2x minus 2 3s are 6, okay. Like that. Second row, first column, minus 1 into 1, minus 1, then x minus 2 into minus 1, x minus 2 into minus 1, minus 1 into x, minus into minus is plus 2, right. The last one, second row, second column, minus 1 into 2, minus 2 plus, you have to multiply these two. That I didn't multiply, just I written there, okay. Now we have to find x only, no? So we are equating the second term with what? 0. So that's, or the third one you can take, that also easy one. So here actually I taken the third one, right? Because little more easier, okay. You'll get the same answer. Minus 1 minus x plus 2 equal to 0. So minus x plus 1, 2 minus 1, 1 equals 0. So 1 is equal to, take minus x to the other side plus x. If we take the second one, you see 4 plus 2x minus 6 equal to 0. 2x, 4 minus 6 minus 2 equal to 0. 2x is equal to 2, x equal to 2 by 2, it is 1. Same answer you'll get, right? So this is how you have to find. Now let's move on to another question. Question number 11, this is a very good question. Show that f of x into f of y equal to f of x plus y. What is f of x? Is given a matrix in x. F of x is cos x minus sin x 0, sin x cos x 0, 0, 0, 1. This is f of x. Then can you say what is f of y? Wherever x comes, you put y. Cos y minus sin y 0, sin y cos y 0, 0, 0, 1. Right? Wherever x comes, you put y. That is f of y. Then f of x plus y. Wherever x comes, you put x plus y. So the first term you should get cos x plus y. Cos x plus y means cos a plus b type, right? What is cos a plus b? In trigonometry you would have studied. Cos a plus b, cos a cos b minus sin a sin b. Cos a plus b is cos a cos b minus sin a sin b. Second term is minus sin x plus y. Minus sin x plus y. So then you must know the formula for sin a plus b. What is sin a plus b? Sin a cos b plus cos a sin b, right? So the trigonometric results also you need here. Otherwise what happens, even after getting that answer, you don't know whether you arrived at the answer or not, right? So otherwise it's a very simple thing. Please listen. For the LHS, you need f of x. Yes, already we know f of x. We need f of y. F of y means I said no. Wherever x comes, you put y. That's all. So first, f of x is given. This is f of x. F of y, replace x by y. Multiply them, f of x into f of y. Both the matrices you multiply. You know how to multiply row by column. Row by column you get this very lengthy expression. Okay, one matrix you are getting with lot of terms. But here you see this is of the type cos a cos b minus sin a sin b. Cos a cos b minus sin a sin b is what? Cos of a plus b. Here instead of a and b we have x and y. So cos x plus y. In the second one you can see minus is common in both. Take minus n outside. See what answer you are supposed to get? You are supposed to get minus x plus y, minus sin x plus y you are supposed to get, right? Minus of sin x plus y. You take minus outside. Sin x plus y. What is sin a plus b? Sin a cos b plus cos a sin b. What is sin x plus y? Sin x cos y plus cos x sin y. Sin x cos y. Yes, sin x cos y plus cos x sin y after taking minus outside. So it is minus of sin x plus y, right? Like that, every term you will get one. Okay, so to do this sum, you need that results. Which results? Sin a plus b, sin a minus b, sin a plus b, right? And cos a plus b. That you must be thorough, then you can do that. Prove that sum very easily, see? And this is same as f of x plus y. F of x plus y means in f of x, wherever x comes, you have to get x plus y. Remaining terms and all what remains same, okay? Now let's move on to the next question. Listen, this is a very good question, one theory question. If A is a 3 by 4 matrix, please listen. A is a matrix, its order is 3 by 4. Then can you say what is the order of A transpose? 4 by 3, right? Okay. A is a 3 by 4 matrix and B is a matrix. B is a matrix. They didn't say its order, right? See the question, what is the order of matrix B? They asked us to find the order of matrix B. I am assuming order of B as m by n. Now I have to find the values of what? M and n, right? Listen. Now what some conditions given. What is there? Such that A transpose B and A B transpose are defined. Both exist. A transpose B. We take the first one. A transpose B exists. Meaning number of columns of the first matrix must be equal to number of rows of the second matrix, right? So what is A transpose order? A's order is 3 by 4. A's order 3 by 4. So A transpose order is 4 by 3. B's order m by n. The product exists means these two must be same. So what can you say? You can say m equal to 3, which implies m equal to 3. M value got it. Now n we have to find. For that, make use of the second one. What's the next one? A B transpose defined. A B transpose defined. A B transpose exists. What is the order of A? A's order 3 by 4. B transpose, B's order we have taken as what? M by n. Let the order of B be m by n. B's order m by n. So B transpose order, reverse it, n by m. N by m. That exists though. That means these two must be same. So you can say n is equal to 4. So you can say n is equal to 4. M value, n value got it. M value, n value got it. So you can say therefore order of B is. Therefore order of the matrix B is m by n. Here m is 3. N is 4, so 3 by 4. Okay, hope you understood. Now let's move on to the next question. Question number 17. Express 4 minus 2, 3 minus 5 as the sum of a symmetric matrix and a skew symmetric matrix. This one is very important result, right? Every matrix can be expressed as a sum of two matrices. One is symmetric, another one is skew symmetric. So they can ask 2 by 2 matrix or even 3 by 3 matrix. Okay, so 3 by 3 matrix they can ask even as a 3 mark question or even 5 mark question. Okay, so first we'll start with the 2 by 2. I'm giving a name for that matrix. I'm taking the matrix as say A. Let A equal to 4 minus 2, 3 minus 5. Listen carefully, the 2 by 2, same way you can do 3 by 3 question. Okay, so this is A. We want A transpose also, right? So we find first itself A transpose, interchange the rows. First row 4 minus 2, second row 3 minus 5. Then let A equal to P plus Q, right? P plus Q, where P equal to 1 by 2 into A plus A transpose, right? A plus A transpose. That is 1 by 2 into A and A transpose, you know, just to add it. 4 plus 4, it is 8. Minus 2 plus 3, right? It is 1. Then 3 minus 2, 1. Minus 5, it is minus 10. So this is P. And you have to prove it is symmetric, right? So how can you prove symmetric? A matrix A is symmetric if A transpose equal to A, right? Here P is symmetric means P transpose equal to P. P transpose. 1 by 2 transpose 1 by 2 itself. It's a scalar, right, as it is. 8, 1. First row, write it as first column. Second row, 1 minus 10. 1 minus 10, right? So now P transpose, and this same as what? P. So therefore P is symmetric. So A we are writing as sum of two matrices, right? Sum of two matrices. One is P, and we proved that P is what? Symmetric. Now you find Q and you prove Q is what? Skew symmetric, right? So for P you know the formula, half into A plus A bar. So same way Q equal to half into A minus A bar, A minus A transpose, right? So that is 1 by 2 into, now we have to subtract it. A minus A transpose, 4 minus 4, 0, minus 2 minus A minus A transpose, right? Minus 2 minus 3 minus 5. So 0 minus 5, you are getting 0 minus 5. Then A minus A transpose, 3 minus minus 2, 5, right? Then minus 5, this become plus 5, 0. So 5, 0. So we have to prove this is Q symmetric. Q symmetric means Q transpose equal to minus Q we have to get, right? So let us find Q transpose 1 by 2, you write as it is. First row, write it as first column. Second row, second column. It is not same as Q, right? Take a minus sign outside, so minus 1 by 2 into. So now we change the sign. 0 is 0 only. 5 become minus 5. Minus 5 become 5. 0 is 0 only. So that is minus 1 by 2 into 0 minus 5 is same as this one, and this is equal to what? Q, right? So you can say that is equal to minus Q. So Q transpose equal to minus Q. So you can say therefore Q is skew symmetric. And one more thing you prove, if you add P and Q, you have to get what? I, right? So let us do that also. So P plus Q is equal to, let us see, you are getting A. What is P here? P is 1 by 2, 8, 1, 1 minus 10, right? 1 by 2 into 8, 1, 1 minus 10. This is P. And what is Q? Minus 10. 8, 1, 1 minus 10. Now plus Q. Q is, what is Q? This is Q. 1 by 2 into 0 minus 5. 1 by 2 into 0 minus 5, 5, 0. Now you add it. When you add, you can take half is common, right? So half into. If you add 8 plus 0, it is 8. 1 minus 5, it is minus 4. And 1 plus 5, it is 6. Minus 5 plus minus 10 plus 0, it is minus 10. So divide every term by 2. If you divide by 2, you are getting 4 minus 2, 3 minus 5. 4 minus 2, 3 minus 5. 4 minus 2, 3 minus 5, right? It is same as what? A. So you can say hence proved. So a 2 by 2 matrix given. So they asked to express this matrix as a sum of two matrices. One is a symmetric matrix, another one is skew symmetric matrix. So A equal to P plus Q, where P is symmetric. So P equal to half into A plus A transpose. Q equal to half into A minus A transpose, and you can prove Q is skew symmetric. Okay. Same way 3 by 3 matrix. Same. This is the procedure. Only thing, instead of 2 by 2, it is what? 3 by 3. Please listen here. Express this 3 by 3 matrix as the sum of a symmetric matrix and a skew symmetric matrix. Take the matrix as A. Immediately you find A transpose, interchanging rows and columns. Then P equal to half into A plus A transpose, half into A plus A transpose. Just add it. 3 plus 3 corresponding terms you add. You know matrix addition, right? So just to stop here, we prove this is symmetric, right? So you find P transpose. P transpose you find out. Half you write as it is. First row write as first column. Second row, second column. Third row, third column. It is same as P only. So P transpose is P. So you can say P is symmetric. Now we find Q. Q is half into A minus A transpose. So half into, you subtract these two, right? A minus A transpose. Q is half into A minus. So you subtract, you are getting this one. You can say it is Q symmetric and you give the proof. So you find Q transpose, take a minus sign outside. After that minus, what you have here is exactly same as Q. So you are getting minus q. So q is q symmetric. Now you find p plus q. Check whether you are getting a. Definitely you'll get it, right? So p plus q. Take half outside and add it. Divide every term by 2. You will get the given matrix A. So you can say hence proved. Okay, now let's move on to the next question, number 18. Listen carefully this question. Find the matrix A. Find the matrix A. Listen very carefully. Such that, okay, see, let us try to find A transpose. Once you know A transpose, then you can find A, right? Transpose of A transpose, right? So first let us see what should be the order of A transpose. So first they given a matrix, then A transpose is another matrix. The two matrices you multiply, you are getting another matrix, right? So by seeing the order, you can find the order of A transpose. Then I'll help you how to do that. What is the order of the first matrix? 3 rows, 2 columns, 3 by 2. Answers order 3 by 3, right? 3 by 3. So if you want to multiply, these two elements must be same, no? So here 2, so A transpose order must be 2 by. Answers order is first and last. Here first and last you are getting 3 by 3. So it should be 3. Here also you should get what? 3. So you can understand the order of A transpose is 2 by 3. So I am finding A transpose first. So A transpose is equal to, let A transpose 2 by 3. 2 rows, 3 columns, right? See? 2 rows, 3 columns. So I'm taking to say A, B, C, D, E, F. Okay, so this is A transpose. Now I have to find that A, B, C, D, E, F and all, right? Then you substitute here. This is A transpose. Then A means you take transpose of that, right? Okay, now I'm substituting all this in the first equation. If you substitute the first equation, the first matrix is 2 minus 1, 1, 0, minus 3, 4. Instead of A transpose, you write what? This A, B, C, D, E, F, right? And right side is the same as that minus 1, minus 2. Okay, so we are substituting in the first equation. When you substitute in the first equation, you get this step. This is a given matrix. This is A transpose, right? This is the answer. Now you know how to multiply. First row, first column, 2A minus D, 2A minus D, right? First row, second column, 2B minus C, like that. Then second row, first column, 1 into A, 0 into D, 0. So A, second row, second column, 1 into B, B, 0 into D, 0, B, C. Like that you can find everything, right? Right side, no change. Now, corresponding elements you can equate. Corresponding elements. Though first and all, if you equate, it's not easy. So what I'm going to do, second row, you see all single numbers, A equal to 1. So you are getting A equal to 1. B, second number B equal to 2, right? B equal to 2. C equal to minus 5. C equal to minus 5. 3 values you got it. Now it is easy, right? Take the first one. 2A minus D is equal to minus 1. 2A minus D. 2A minus D is equal to minus 1. A value, you know, it is 1. So 2 into 1. 2 minus D is equal to minus 1. So minus D, take that side. So plus D is equal to 2 plus 1, it is 3. So D value 3. And you can equate this. 2B minus C. 2B minus E equal to minus 8. B value 2. Substitute 2 2s are 4 minus E equal to minus 8. Or plus E equal to 8 plus 4, right? 4 plus, it is 12. Then take the last one. We are taking the third one. 2C minus F is equal to minus 10. C value minus 5. So 2 into minus 5, it is minus 10 minus F is equal to minus 10. So take minus F to the right side, plus F is equal to minus 10 plus 10. You will get what? 0. So now you can write A transpose. A transpose is first row ABC. What is ABC here? 1, 2, minus 5. 1, 2, minus 5. Second row DEF. That is 3, 12, 0. This is A transpose. Don't stop here. We are supposed to find the matrix what? A. You are getting A transpose. Now we take the transpose of this, right? So A equal to A transpose, the whole transpose. Already you know A transpose. You take the transpose of that. So A equal to first row. Write it as first column. First row is 1, 2, minus 5, right? Second row 3, 12, 0. Okay, so this is your answer for question number 18. Now let's move on to the next question. Question number 20, in which I am taking the second part. Listen very carefully. If one matrix given is skew symmetric, one matrix given and they said it is skew symmetric. So I am giving a name for that matrix. So let A equal to 0 P3 2Q square minus 1 R1 0. So it is given skew symmetric. Read the question very carefully. Sometimes they may say it is symmetric, right? But here they said it is skew symmetric. You find the values of P, Q, R, right? So since A is skew symmetric, what can you say? Since A is skew symmetric, you know A transpose is equal to minus A. That's all. Now it's very easy, right? A transpose. Take the transpose of this matrix. First row 0 P3. Second row 2 Q square minus 1. Third row R1 0. This is A transpose equal to minus A. A we know, minus A. Additive inverse, right? Change the sign. So when you change the sign, you get 0 minus P minus 3 minus 2 minus Q square plus 1 minus R minus 1 0. Now two matrices are equal. You know when two matrices are equal, the corresponding elements are equal, right? See what they asked to find? P, Q and R. See, P value is equal to what? Minus 2. So you are getting P equal to minus 2. Second one, so next one, Q square, right? Q square equal to minus Q square here, corresponding elements. Bring that minus Q square this side. Q square plus Q square, 2Q square equal to 0. Q square equal to 0 by 2, 0. So Q also what? 0. Then you have to find R value. Minus R equal to 3. Minus R equal to 3. Change the sign. R equal to minus 3. So that's all the final answer. Write them in order, right? You can say P equal to minus 2. Q equal to 0. And R equal to minus 3. Now let's move on to question number 22. Look at the question. Very good question. Listen very carefully. Some theory question, okay? So, but it's very simple. Don't worry about this. So mathematics, we learn all the sums, but theory we find difficult. But in our science subjects, theory you study, but problem you may find difficult, right? But there are some students, they like problems, right? Okay, look at this. Let A and B be two symmetric matrices. Listen carefully. A and B be two symmetric matrices. Okay. So it is given in the question, A and B are symmetric. Okay. So we start like this. Since A and B are symmetric, what can understand, you know? They are all square matrix, right? They are square matrix and A transpose is A. B transpose is B, because they said A and B are symmetric matrices, okay? So that is A transpose equal to A and B transpose is equal to B. So these you can use it, okay? Now, prove that, listen very carefully, prove that AB equal to BA if and only if AB is a symmetric matrix. AB is a symmetric matrix. So if there is if and only if, you have to prove two parts. One part you have to prove and you prove the converse also. I'll tell you what it is. First, prove that AB equal to BA. You prove this if AB is a symmetric matrix. So you assume AB is a symmetric matrix. You prove AB is equal to BA. Second time, you assume AB equal to BA and you prove AB is symmetric matrix. Okay, and this is statement 1, this is statement 2. In the first case or in one case, you assume 2, you prove 1. Second case, you assume 1 and you prove 2. Okay, assume 1, prove the other one. That's all. And you reverse it. Okay, so here first case, case 1. Listen. So given, what is given here? AB is a symmetric matrix. AB is a symmetric matrix. To prove, what you have to prove? AB equal to BA. Let us see. Listen, AB is a symmetric matrix. You have to prove AB is equal to BA. Please listen how to prove this. A matrix is symmetric. When can you say a matrix is symmetric? Its transpose is that itself, right? So P is symmetric means P transpose is P. AB is symmetric means AB transpose is AB, right? So here AB is symmetric, so you know AB transpose is equal to what? AB itself. So you know reversal law, properties of transpose. AB transpose means it is B transpose into A transpose is equal to AB. But you know B transpose is same as B only, right? Because A and B are symmetric matrices. So B transpose can be written as B. A transpose is same as A. Equal to right side is what? AB. You are getting AB is equal to BA, right? So first part is over. So given AB is symmetric matrix, we prove AB equal to BA. Case 2, assume this and you prove this one. Assume AB equal to BA, you prove AB is a symmetric matrix. So that is case 2. Given AB equal to BA, we have to prove AB is symmetric, right? AB is symmetric. So how can you prove AB is symmetric? You find AB transpose, right? You have to get what? AB. AB transpose equal to AB. If you get, you say AB is what? Symmetric. What is AB transpose? B transpose. B transpose into A transpose. B transpose is same as B. A transpose is same as what? A. Because now this BA can be written as what? AB. Why? How we are getting this step? Because in the question they said A and B are what? Symmetric. So this is an important question. So practice well this one. Okay. Now just I am going to help you another question. Question number 23. Look at the first part. If A and B are symmetric, so here it is given A and B are symmetric, right? So immediately you know, since A and B are symmetric, what can you say? A transpose equal to A and B transpose is equal to B, right? A and B are symmetric, it is given in the question. Of the same order. Prove that AB plus BA is symmetric. We have to prove AB plus BA is symmetric. What is the condition for symmetric? You take the transpose, there is no change. P is symmetric means P transpose equal to P. So whatever you have to prove, so we have to prove this is symmetric. So you find its transpose. You have to get that itself, right? So we have to prove AB plus BA is symmetric. What is the condition for symmetric? You take the transpose, there is no change at all, right? To prove P is symmetric, P transpose equal to P. So what do you want to prove? Which one you want to prove symmetric? We want to prove this as symmetric, right? So take the transpose of that. So AB plus BA transpose you take and you are supposed to get what? AB plus BA itself. If you are able to prove this, you say AB plus BA is what? Symmetric. Now let us see how to do this. Very simple thing. You must know the properties of transpose. Okay, that already I taught. So the addition only, no? A plus B transpose, A transpose plus B transpose. Only for multiplication it come in the reverse order, right? AB plus BA transpose means AB transpose plus BA transpose. Now for multiplication is there, so you have to write in reversed order, right? So AB transpose means that is B transpose into A transpose plus BA transpose is A transpose into B transpose. You know A and B are symmetric, so B transpose is same as B, A transpose is same as A plus A transpose is A, B transpose is B, right? Because the reason A and B are what? Symmetric. That is common, it's given in the question, right? So you are getting AB plus BA transpose is AB plus BA itself. So AB plus BA is symmetric. Suppose if you get AB plus BA transpose is minus of AB plus BA, then you will say it is what? Skew symmetric, right? Okay, now just last one more question. If A and B are symmetric, again A and B are what? Symmetric. So immediately you can start. So since A and B are symmetric, since A and B are symmetric, what can you say? A transpose equal to A and B transpose equal to B, right? Now listen. What they asked to prove? AB minus BA is skew symmetric, right? AB minus BA, AB minus BA is skew symmetric. What is the condition for that? How can you prove something, some matrix is skew symmetric? You take the transpose, you have to get minus of that matrix, right? P transpose is minus P, then you say P is skew symmetric, right? So here AB minus BA is skew symmetric, we have to prove. So take the transpose of that and you are supposed to get minus of AB minus BA. Minus of AB minus BA means it is what? BA minus AB, right? So minus AB, yes, minus into minus is plus BA. Let us see whether you are getting this step. Please listen. So this is subtraction only, no? So separate like addition only. Only for multiplication you have to reverse the order. So this is AB transpose minus BA transpose. Now reversal law. AB transpose means B transpose into A transpose minus BA transpose is A transpose into B transpose. Now B transpose is same as B, A transpose is same as A. Here A transpose is A, B transpose is B because A and B are what? Symmetric. Then A minus B can be written as minus of B minus A, same thing only. BA minus AB can be written as, take a minus and outside. So the minus become plus and the plus become minus. This is what you are supposed to get. So you can say AB minus BA is what? Skew symmetric. So the first exercise, very simple one. Don't leave any question, right? So I taught the important questions from the first exercise. In my next video, I'll teach you the important sums from the second exercise.